Alright, so today we're going to be getting into what we call radicals and talking a little bit about what radicals are. We're also going to be simplifying radicals in today's lesson. So first thing we need to do, though, is we need to get a general understanding of what a radical is and what the parts of a radical are. So on your notes, what I want you to do, we'll start up here at the top. And what I want you to do is in that first box right here, I want you to write in the number 3. Okay, go ahead and write in the number 3. Then in the big box underneath, I want you to write in the number 125. And then we're going to label some information and go through and talk about what each of these numbers represents and then what the signs represent. So today we're talking about parts of a radical. So with a radical, we want to look up at the top. First, we want to notice this radical sign, this big sign that you see right here, okay? This whole sign that we have indicated above the 125 and underneath the 3. That sign is what we call a radical symbol. Go ahead and fill that in. Radical symbol. Now the radical symbol just basically means the inverse of when we square something or cube something. Really what we're just paying attention to here is what numbers we have, and then this sign represents that we're going to take, usually we're understanding to be the square root, but in this instance we're looking at it as the cube root, which is why we have the 3 located up in the top left corner. Now that 3 that we have located up here is actually what we call our index. So go ahead and write that number, or write that word in, index, I-N-D-E-X. And then we have the number that's located underneath the radical symbol. And this number that we see right here is called the radicand. Now that's spelled R-A-D-I-C-A-N-D. Radicand. And then all these parts put together, everything you see up here on the board is what we call the radical. So today when we talk about simplifying radicals, we mean that we're looking at everything you see up here on the board. The index, the radical symbol, and the radicand. And we're taking all 3 of those things, which is known as the radical, and we're simply simplifying it down to its simplest form. Now, down here at the bottom it says, if the blank is not written, then it's automatically a blank. So in that we're going to write, if the index is not written, so if there's no index up here where we see this 3, if there's no index up there, then what that means is it's automatically a 2. And we know that because when we have numbers, let's take something easy like the square root of 4. Okay? We know the square root of 4 is equal to what? 2. And the reason we know that is because that's the same thing as 2 squared. 2 squared is equal to 4. So what's basically going on here is we understand that this is what we call the square root. And then since this is a square root, we understand that the 2 is not needed on the outside. So that's why we just understand it to be there. We understand that this radical symbol is understood to be the square root. So if it's just the radical symbol and no index, then we understand that that is going to be a square root of a number. Okay? Now, real quick, what I want you to do over here on the right-hand side, and this will be on the back of your page so you can flip it over. But on the back of your page, I want you to go through and I want you to write down 2 things. I want you to determine what the index is, and I want you to identify what the radicand is. We'll do the first one together. So with the square root of 24, we want to identify 2 things. We want to identify the index, and we want to identify the radicand. I'm going to abbreviate them as I and R. So the index in square root of 24 would be what? 2. Because we understand that outside here is nothing. There's no number there. So that's understood to be a 2. The radicand in this number, or this problem, would be what? 24. So we would write a 24 to indicate what the radicand is. Let's look at the next one. We have our index, and we have our radicand. So in this one, the index is going to be what? 4, because we look at the number that's on the outside, so that's going to be 4. And then the radicand is the number underneath. Now this one has some variables with it, so what is it? 128 into the 8. So we would write down everything that's underneath the radical symbol. All right, real quick, see if you can identify the rest ones. We'll pause the video, give you some time to write those down. All right, so real quick, welcome back. I want you to go ahead and look over your answers. If you need to pause the video, you can pause the video so that you can check your answers. But look over each answer, identifying what the index and the radicand are. All right, so after we've done all this, next thing we want to do is we want to open up our notes on the inside. So go ahead and open up the inside of your notes. And if you haven't already, I've already listed all 4 problems that we're about to work here. But up at the top, just somewhere on your page, what I want you to do first is I want you to write down the perfect squares, okay? I want you to write down some of the perfect squares. So the first one we're going to start with 1. Then we're going to go to 4. After 4 would come 9, 16. After 16, we would have 25, 36, 49, 64, 81, bless you. After 81, we would have 100, we would have 121, and then 144. And we could keep going with these perfect squares, but really those first 12 are the ones we're going to be identifying here to be able to see what our problem will work as. Okay, so let's look at our first example. So for number 1, I told you to go ahead and write down the square root of 80. So this is going to be number 1 on your notes. And what we're doing now is we're simplifying these. Now, if you notice, all of these problems are going to have an index of 2. We're only going to worry about indexes of 2. So here we're going to be looking at the square root and then of a number. In this case, the radicand is going to be 8. Now, to break this down, the way we're going to work these problems is first we want to look at all of our perfect squares. We want to look at all these numbers up here at the top, and we want to see what the biggest number is that will divide 80 perfectly. Now, we can pick some smaller numbers, we can do some bigger numbers, but looking at these, does anybody see a number that would divide 80 perfectly? How about the number 4? All right, or 16. Would 16 divide 80? Sure. All right, would 64 divide 80? How many times? No, not once, not perfectly. All right, we can't go into that perfectly. Maybe 16 though, maybe 4. Let's say we went with 4 though, okay? So let's take 4 for instance. Now, what we're going to do here to get our answers, we're basically going to factor this down. That's how I like to solve these. There's a couple different ways. If you can find the biggest number up here, it makes it easier for you. But I want to factor this, okay? So when I factor 80 down, let's start with 4. If I was to take that number and divide it by 4, if I took 80 and divided it by 4, then that would be what? 20. Okay, so I would have 2 numbers here, 4 and 20. Now, looking at 4 and 20, how do I break down 4? All right, 2 and 2, so I'm making a factor tree. I'm going to break that down into 2 and 2. How would I break down 20? All right, I could do 10 and 2. I could do 5 and 4, lots of different combinations for that one. So let's do 2 and 10. All right, and then how would I break down 10? Into 5 and 2. Now, the reason I stopped with these other numbers is because if you look at 2, 2, 2, 2, or 5, will any of those numbers break down any further other than 2 and 1, or 5 and 1? No. So what I do now is, since this is understood to have an index of 2, I want to find pairs, okay? Pairs of numbers that exist, or that work. And I want to focus on all these numbers that I got here at the end. So I'm going to just focus on these numbers, okay? Those are the ones that I'm looking at. So when I look at them, how many pairs of 2's do I have? Well, I'm going to circle them. I have 1, 2, so there's a pair. So if I have a pair, I'm going to write that down, 2. Okay? Then I'm going to go over to my next one, and I have 2 pairs of 2's. So if I have 2 more pairs of 2, I'm going to write that down, times 2. And then if I look at this 5, do I have a pair of 5's? No, I only have how many 5's? 1. So since I only have 1 5, that's actually going to stay underneath the radical symbol. So what I'm going to do is I'm going to write the radical symbol, and I'm going to put the 1 number left over underneath it. So when I multiply this out, I want to multiply my two outside numbers. So what's 2 times 2? 4. And then I'm going to get 4 on the square root of 5. That would be the most simplified this problem could get. Now, that's one way of working it. Another way of working this problem would simply be by dividing it by the biggest number up here. So if I was to look, once again, I said 16 was the biggest number that would divide 80. So if I divide 16 by 80, I get the square root of 16 times the square root of 5. Because I know 80 divided by 16 is equal to 5. From here, I can say the square root of 16 is what? 4. So then I get 4 times the square root of 5, which would be 4 on the square root of 5. So that's the easiest way if you know how to divide, and you can divide pretty easily. But a lot of times it's going to be better to break it down like a factor tree, like you see on this side, to get your problem or answer if you're more of a visual person. If you're more of a mathematical person that can think through it, then divide it out and you can get your answer as well. So pretty easy to go about this process. Any questions on this one? All right, so number 2, what I want you to do is I want you to try this one on your own. Pick a way to break it down and see what you come up with. So I'm going to give you a few minutes to do number 2, and then we'll go over this problem up here on the board. All right, so looking at this problem, what we got to do first, if you notice, this one doesn't, you have to kind of think through it, divide a lot of numbers if you want to do it the fast way. If you start trying to think of numbers, it was kind of tough on this one. So here's what I would suggest doing. I would do the factor tree on this problem. So with this problem, when I do my factor tree, I notice that it ends in 6, so I'm automatically going to say that this probably divides by 2. Okay, so that's what I'm going to do first. I'm going to divide it by 2. So if I divide this by 2, I know 19 divided by 2 is going to give me what? All right, 9. So I'm going to get 9 and then carry my 1. So then 16 divided by 2 would give me 8. Okay, so I should get 98 when I break that down. So 2 and 98. Now, I can keep going with this. 98, I don't know what it divides by. I know it at least divides by 2 though, right? So let's divide it by 2 and see what we get. So if we divide it by 2, 98 divided by 2, let's start with the 9. 9 divided by 2 is 4. And then it's going to be 1 left over, so that would be 18. So 18 divided by 2 would be 9. So now it breaks down to 49. Oh, this is nice. All right. So we've got a pair of 2s. All right. What do we know 49 breaks down into? 7. So we break that down into 7 and 7. All right. Now, 7 break down any further? No, so it looks like we got a pair of 7s. So with this one, we have 2 2s, so that's going to be 2. We have 2 7s, so that's going to be 7. And then we have nothing left over, so does anything go under radical here? Nope, because we have 2 2s and we have 2 7s, so nothing left over. So 2 times 7 would mean our answer is going to be what? 14. So it actually worked out to where 196 is going to be a perfect square of 14. So 14 times 14 should give us 196. A lot of y'all guys got home. Okay. Now, understand, we can always break these down. That's why I like the factor tree, because I can actually divide by smaller numbers in a factor tree as to where looking at these perfect squares, there may not be one that works for a while. So it's important that if you do the squares, you know all those factors. But when you look at these, you may want to be able to break those down. Okay. All right, let's look at another example. And this will be number 3. So in number 3, we're going to look at the problem, the square root of 45, x to the 4th, y to the 3rd. Now, when we throw variables in there, we get into a little bit of a different situation. We still have an index of 2, understood. But when we look at the rest of the problem, the variables kind of mess us up. So let's start with our numbers first. So on this one, we have 45. So with 45, we can break that down into 9 and 5. And then once we break that down into 9 and 5, we know 9 will break down into 3 and 3. So there's a pair. And then we know 5 won't break down, so 5 stays 5. So what I have here is I have 2 3s, so that's going to be 3s. And then underneath the radical, I have a 5. So that's going to be the breakdown of this problem. Now, to do these variables, what I want to do is I basically want to take and divide the numbers on top, or the exponents here, by the index. So in this problem, what is 4 divided by 2? 2. So if it divides it perfectly, then I just write x squared on the outside. With the 3, though, If I divide 3 by 2, I have how many? I have how much with